back. Section 10, Matrix Arithmetic, Transposes and Powers of Matrices, 0-1 Matrices. Introduction. A matrix is a rectangular array of numbers. A matrix with m rows and n columns is called an m by n matrix. Plural of the word matrix is matrices. A matrix with the same number of rows as columns is called a square matrix. So let's see an example before I proceed. Write down an example of a 3 by 2 matrix and a 4 by 5 matrix. So, you may write matrices with parentheses or you may write matrices with brackets. Okay? Okay. Let's look at this matrix. The example here required is 3 by 2 matrix. So I need 3 rows and 2 columns. Okay. The next matrix example they want is a 4 by 5 matrix. So I need a 4 rows and 5 column matrix. So what does that mean? I have here 3 rows and 2 columns. Okay, let's zoom in. 3 rows and 2 columns. So I can put in whatever number I like. -1, 2, 3, 0, 1 over 2, -5 over 3rd. That's a matrix which is 3 across and 2 columns. Here is a matrix which has 4 rows and 5 columns. I can write whatever numbers I like. I'm allowed to have a column full of zeros. I'm allowed to have a column full of ones. I'm allowed to have any sort of numbers. Pi. Sorry. Square root 3. So I'm allowed all sorts of numbers. So this is a 4 by 5 matrix. This is a 3 by 2 matrix. All right. So matrix is simply an arrangement of numbers in a rectangular form. Rows versus columns. If the number of rows is equal to the number of columns, we call such a matrix a square matrix. Let's imagine, right? A square matrix. Look at that. 2 rows, 2 columns. That's an example of a square matrix. Okay. Now, 2 matrices are said to be equal if they have the same number of rows, same number of columns, and the corresponding entries in every position are equal. So, in other words, if I take this matrix and copy it, instead of 2, I have a 1 here. Then, even though sizes are same, the respective elements here are same, this one entry is different from this entry, so they are not equal. I hope it's clear. All right. Some notations. So here is an m by n matrix. M rows, first row, second row, so on, and n columns, first column, second column, so on. So you see when I was saying first column, second column, so 2 nth column, whereas first row, second row, mth row. So the first index represents represents row, the second index represents column. Okay, the ith row is the 1 by n matrix. So if I'm on the ith row, so first row that's 1, second row that's 2, mth row that's m. So ith row will have I here, ai1, ai2, so on. Likewise, the jth column, is represented by the second index. That's the second column. So the jth column will be j in place of 2. So A1j, A2j written in a column. So ijth element is ith row element and jth column element, that is Aij, is a number in the ith row and jth column. A convenient shorthand for expressing matrix A is to write in bracket Aij. Alright. Some people use parentheses, some people use brackets, they are okay. Okay. Let A be matrix Aij. So instead of writing an entire box like this, you can simply write Aij. B is the matrix Bij. They both be m by n matrices. What does that mean? Both these matrices have m rows and n columns. How do you add matrices? Well, you add matrices term by term. So let's write down 3 by 2 matrices and find their sum. Okay, so I will write a matrix that is 3 by 2. All right. So let's see. Suppose I have 2, 1, 0, negative 2, 0, 3, 4. That's one matrix. I need to add two matrices. I need them to be of the same size. So instead of 2, here I have say 5, 0, negative 3, 1, 2, 3. So how do I add these two matrices? Well, I will add them basically term wise. What does that mean? What goes here? 2 plus 5 goes here. What goes here? 1 plus 0 goes here. What goes here? Negative 2 plus negative 3. Negative 5 goes here. What goes here? 4 plus 3, 7. What goes here? 3 plus 2, 5. What goes here? 0 plus 1, 1. Okay, this was addition of matrices. So notice I can add two matrices as long as they are of the same size. That way there are individual numbers. So let's subtract two matrices. Instead of addition, let me subtract these two matrices. How do I subtract? Well, it will be a matrix of the same size. Okay. Now I'm subtracting. 2 minus 5 is negative 3. 1 minus 0, 1. Negative 2 minus 3, positive 1. 4 minus 3, positive 1. 3 minus 2, positive 1. 0 minus 1, negative 1. So that's how you subtract matrices. The result is a matrix of the same size. Okay. Now subtract the second matrix from the first. We just did that. Now multiply the first matrix by half. This is called scalar multiplication. What does additive identity look like? Okay, so let's take the first matrix and multiply it by half. What does that even mean? I'll take this matrix and multiply it by 1 over 2. Okay, what this means is I get a matrix of the same size, but each entry is being multiplied by 1 over 2. 1 over 2 times 2 is 1. 4 1 over 2 times 4 is 2. Here, 1. 1 over 2 times 1 is 1 over 2. 3. 1 over 2 times 3 is 3 over 2. Negative 2. 1 over 2 times negative 2 is negative 1. 0. 1 over 2 times 0 is 0. So this is scalar multiplication. What is scalar multiplication? You take one number and multiply it to every entry here. That's scalar multiple. Okay? What was the question? Next, what does additive identity look like? Additive identity means that matrix which added to your chosen matrix, any chosen matrix. So suppose I want to add this. Okay. What should I add so that I get the same matrix back? First of all, whatever I add has to be the same size so I can add it back. So, question is what should these be so that this plus this is this? Well, it's a matrix full of zeros. That is your additive identity in matrix addition. So, remember the size has to be the same and then you add things. All right. Matrix multiplication. Let's come to this in our next video. Until then.